Okay, so hello and welcome to this video tutorial for E411 Statics and Dynamics of Simple Mechanisms. So we have this problem here. It says a train starts from rest at station A and accelerates at 0.5 meters per second squared for 60 seconds. Afterwards, it travels with a constant velocity for 15 minutes. It then decelerates at 1 meter per second squared until it's brought to rest at station B. Determine the distance between the stations. So personally, I feel the best approach for a problem like this involves visualizing the problem. So we could draw up a velocity time graph here, since we've got three different velocities that it's describing. So on the vertical, I'd have velocity, and on the horizontal, I'd have time. Doesn't have to be to scale. We have this first section here where the train is accelerating. We have this 15-minute section here where the train is at constant velocity, and we have this, we'll soon find 30-second period here. Oh, Microsoft is not liking me today. Give me a straight line. There we go. Okay. So it says it accelerates at 0.5 meters per second squared in this first 60-second period. Let's just pick a different color here. Let's just write 60 seconds here. And we can show that it's accelerating at 0.5. Note here that acceleration is the gradient of the velocity time graph. The reason is because acceleration describes the rate of change of velocity per unit time, right? And that's exactly what a gradient is. So for every one across, or every 1 second of time, the velocity is increasing by 0.5 meters per second. If it's doing this for 60 seconds, hopefully it should be evident to you guys almost intuitively that this should be 30 meters per second here. And then here it's describing a gradient of -1 effectively. So let's just label that. This constant velocity section is 15 minutes. So let's just label that there. 15 mins. And this final section here, again, if it's starting at 30 meters per second and is decelerating to 0 meters per second at a rate of 1 meter per second, hopefully it should be evident that this should take 30 seconds, okay? Almost intuitively, that this should take 30 seconds. If you didn't know already, if you want to determine the distance traveled from a velocity time graph, it's a simple case of taking the area under the curve. So in this instance, we have kind of three shapes to determine the area for. We've got this right angled triangle at the start here, this rectangle effectively in the middle, and this also right angled triangle on the right here. Let's start with this first triangle. If you didn't know how to calculate the area of a triangle, it is half times base times height. So that would be half times 60 seconds in this context, times 30 meters per second. And this is equal to 900. My bad. The rectangle in the middle, if you don't know already, the area of a rectangle is given by height times width. So in this context, we've got 30. And we want to make sure that our units are consistent. We want to describe this 15 minutes in seconds. So there are 60 seconds in a minute. So we could describe it as 15 times 60. And this is equal to 27,000. And the final triangle, half times base times height again, half times 30 times 30 equals 450. The question's asking, determine the distance between the stations. Okay, well, we just need to add these together then, don't we? And that gives us 28,350 meters. Okay, awesome. If you have any questions or comments about that problem, then leave them down in the comments below. Otherwise, thank you very much for watching.